Hello friends. Yesterday we came at the point uniform circular motion. That is the object moving in a circle with constant speed. It is called as uniform circular motion. And when the body performs circular motion, at that time centripetal force acts on that body F is equal to mv square upon r. Now, the distance traveled by the planet in one revolution is equal to the perimeter of the orbit, and it is equal to 2 pi r, where r is the distance of the planet from the sun, and time taken by planet, that is period of revolution, is equal to capital T. Now we know the equation of velocity. Velocity v is equal to distance upon time, and for this planet v is equal to distance, that is equal to perimeter, equal to 2 pi r upon time, that is period of revolution. It is equal to capital T. Now the velocity of planet is equal to 2 pi r upon T. Now we know the equation of force F is equal to mv square upon r. Now put the value of v in the given equation. See that equation, that is put the value v, that is equal to m in bracket 2 pi r upon t bracket square upon t is equal to 4m pi square into r upon t square. Now multiplying and dividing by r square, we get f is equal to 4 pi square into m upon r square into r cube upon t square. Now according to Kepler's third law, t square upon r cube is equal to k, it is constant, and so r cube upon t square is equal to 1 upon k by taking reciprocals on both sides. And then new equation form of centripetal force F is equal to 4m pi square upon r square into k. But in this equation 4 is constant, m is constant, pi is constant, again k is constant. That is 4m pi square upon k. This value is constant, and so F, the centripetal force of the planet, it depends only on its distance from the sun. It is inversely proportional to square of the distance of planet from the sun, and thus the centripetal force of any planet, it is inversely proportional to square of its distance from the sun, square of its distance from the sun. Now next topic, that is Earth's gravitational force. Now there is question, will the velocity of a stone thrown vertically upward remain constant, or will it change with time? How will it change? Why does not the stone move up all the time, and why does not it fall down after reaching why does it fall down after reaching a certain height? What does its maximum height depend on? And the question of answer of all these questions, that we know that Earth exerts the gravitational force on any object on the surface of Earth or near the surface of Earth, near the Earth. Earth attracts each and every object near it towards itself. And as we throw the stone in vertically upward direction, Earth exerts gravitational force on that object, and due to that force, the velocity of that stone, it decreases gradually. And at certain height, the velocity of that stone, it is equal to 0, and from that height, it again moving vertically downward direction towards the center of Earth. That is, Earth exerts gravitational force on each and every object, and so that object, it is moving towards the center of Earth. It is Earth's gravitational force. As we know that when force acting on any body, then it produces acceleration. Due to that force, the velocity of that object is changed, velocity of that body is changed, that is acceleration is produced. As we learn here that Earth exerts gravitational force on any object, it means that there some acceleration is produced, and that acceleration is called as acceleration due to gravity, or it is also known as gravitational acceleration, and it is denoted by symbol small g. Now acceleration, it is the vector quantity. It is the vector quantity, as according to Newton's law that direction of acceleration is towards the direction of force. When any force exert on body, at that time it accelerate, and acceleration, it is towards the direction of force. It is Newton, one of the Newton law of motion, and according to that law, the direction of gravitational acceleration, it is towards the center of the earth, that is, it is in vertically downward direction. Now the value of g, that is value of acceleration due to gravity or gravitational acceleration on the surface of earth, we can calculate the value of g by using Newton's universal law of gravitation. If capital G, it is universal constant, capital M, it is the mass of earth, and small m, it is the mass of the body or object situated at a distance r from the center of earth. Now according to the law of gravitation, universal law of gravitation, the force between the object which is at a distance small r from the center of earth and earth is equal to capital G into capital M into small m upon r square. Now we know that the weight of any object, it is equal to mass into gravitational acceleration. And so F is equal to mass of that object into gravitational acceleration. Weight of that object, W, that is F, is equal to mg. Now later we learn about the weight. Now that weight of the object, it is equal to force of attraction, and so we equate both the equations, then we get mg. We equate equation number 3 and equation number 4. See that both equation, observe that both equation, by equating both the equations, mg is equal to gmm upon r square. Now small m get cancelled, and so small g, that is gravitational acceleration, is equal to gm upon r square. That is the gravitational acceleration, it depends on the distance of the object from the center of earth. If the object is on the surface of earth, then the distance of that object from the center of earth, it is equal to the radius of earth. At that time, the value of g is equal to gm upon r square, and we know the values of capital G, M and capital R, that is gravitational constant. The value of gravitational constant is equal to 6.67 into 10 raised to minus 11 Newton meter square per kilogram square, and the mass of earth, it is equal to 6 into 10 raised to 24 kilogram, and radius of earth is equal to 6.4 into 10 raised to 6 meter. By putting all these values in equation number 6, at that time the value of gravitational acceleration, it is equal to 9.77 meter per second square. Meter per second square, it is the SI unit of acceleration. Acceleration, it is the vector quantity, and its direction is towards the center of earth, and its value on the surface of earth, it is equal to 9.77 meter per second square. Now this value of G, it is not constant everywhere on the surface of earth due to certain shape of earth and due to rotation of earth. That value is different on the surface of earth. Now we consider three conditions to measure the value of G. That is, first, the value of variation in the value of G along the surface of earth. Second, variation in the value of G with change in height of that object from the surface of earth, and third, it change or variation in the value of g with depth, that is below the earth, inside the earth. Now we consider first condition, that is variation in the value of g by change it change along the surface of earth. As we know that earth bulges at the equator and it is flatter at the pole. So its radius, it is largest at the equator and smallest at the pole. As the radius increases, its value decreases, and so the value of g, it is highest at the poles, because at the pole its radius, it is smallest, and so highest value of acceleration, gravitational acceleration, is 9.832 meter per second square at the poles, and it is lowest at the equator, and that value is 9.78 meter per second square. That is, if we move from equator to poles, at that time the value of g increases, or if we move from poles to equator, at that time its value decreases. Its highest value is 9.832 meter per second square, and its lowest value is 9.78 meter per second square. So the value of g is not constant on the surface of earth due to rotation of the earth and due to certain shape of earth. Now second, variation in the value of g with height. Now it is the earth. As we move from the surface of earth in upward direction, then radius, that is the distance of the object from the center of earth, increases. As that distance increases, we know the equation of small g is equal to gm upon r square. That is the distance of object from the center of earth. As that distance increases, the value of g decreases. As the height above the surface of earth increases, the value of g decreases. If the height of the object, it decreases, at that time the value of g increases. Now, third condition, that is the variation in the value of g with depth. Now, as we move or we go inside the earth, that is towards the center of earth. Now, we know that earth is spherical in shape or elliptical, it is spherical in shape, oval shape. As we move towards the center of earth, at that time radius decreases. According to mathematics, the value of g, it is inversely proportional to distance. It is inversely proportional to r square. As the value of r decreases, according to mathematics, its value must be increases. But again there is another condition. As the object go inside the earth, at that time, as the radius of earth decreases, so the volume, that is mass of that earth, it also decreases. As the value of g, it is directly proportional to mass of earth. As the mass decreases, so the value of g also decreases. And so with both effects, by considering both the effects, that is the radius decreases, mass decreases, the value of g is decreases as we go inside the earth, and at the center of earth the value of r is equal to 0. Value of r is equal to 0. At that point, the gravitational acceleration is at that position. The value of g, it is lowest or it is equal to 0. So at the center of earth, weight of any object is 0, but mass is, that object has certain mass. Mass is not 0 at the center of earth. So there are three conditions that affect on the value of g. First, on the surface of earth, The value of G, it is maximum at the poles, it is minimum at equator. As height above the earth increases, the value of G decreases, and inside the earth, if we move towards the center of earth, the value of G again decreases. The value of G decreases. Now, there are two physical quantities are given, mass and weight. ज्याला आपण मराठीमध्ये वस्तुमान आणि वजन असं म्हणतो. आपण जनरली कोणालाही कुठल्याही वस्तूचं वजन किंवा बाजारातून आपण कुठली गोष्ट आणली तर आपण असं म्हणतो